Hey everyone, so in today's lesson, we are going to lesson 1-6. So we have our learning objective is to translate English words into math language. Our learning objective is to explain the process we use when translating words into mathematics. So let's take a look at our do now. Hey everyone, so let's take a look at our do now for today. Today what we are asked to do is evaluate the following. So when you are asked to evaluate, what you want to do is identify what they gave you. So they said n times p divided by n plus p when n is equal to 9 and p is equal to 15. So in my problem, I'm going to identify all of my n's and all of my p's. So that's the first thing I'm going to do. Next thing you want to do is substitute. When we are asked to substitute, what we're asked to do is replace. So I'm going to identify my n, which is 9. And in the top piece, we're asked to do 9 times p divided by my n, which is 9, plus p. All right, so step 1, substitute. Nice and easy, I could get myself that point. Next thing I suggest is you do the rest in the calculator. So I'm going to take this fraction and I'm going to take out my calculator and input it there. So I have my calculator right in front. I made the screen a little bit bigger so you guys could see. I am going to do 9 parentheses 15. And what this means is 9 times 15. I'm going to press enter. Do not do this all in one shot. The calculator is a great tool, but we need to know how to use it. Okay, so now I'm going to do the bottom. 9 plus 15, enter, 24. At this point, I have the numerator simplified, the denominator simplified. I'm going to divide this. 135 divided by 24, enter. It gives me a value of 5.625. Now that I have that answer, I don't want to give that answer as my final answer. What I want to do is I want to change it to a fraction. So I am going to press math right here, math, fraction, which is just enter, and then enter one last time. And that's going to simplify the answer for you in its most simplest form, 45 over 8. All right, so let's take a look at the next piece. All right, for the next thing, what we are asked to do is do some sort of thinking. It says, how do we translate English words into math? So here are the steps for translating words into math. Number 1, you will need to read the problem and underline or highlight keywords. So anytime you read it once, and you should be reading it twice. The first time you normally read something, it doesn't stick in your head. The second time around, it's a little more concrete in your head. We want to read the problem, I would say at least 2 times. That way I could really understand it. Highlighting, underlining important keywords. Keywords that deal with some math operations and stuff like that. Next thing, define your unknown. Define your variable. So you must always have a let statement. And you'll see what that means. All right, number 3, translate by using operations, numbers, and unknowns or an unknown. So once I've highlighted, I've already identified these pieces of information. So this should be a little bit simpler to do. And the last thing that you always want to do is read the math, read your equation. Does it make sense? Sometimes it looks like it's right, but it doesn't make sense to the problem. So let's look at example 1 and let's see what we are going to do. All right, here we have example number 1. And what we're doing is we're translating our words into some algebraic expression, and this is our first level. So this types of questions should be the most simple types of problems that you're going to feel very, very confident in. Let's read number 1. It says, if x represents a number, then write an expression for the sum of a number and 3. Okay, so I read it once. I'm going to read it one more time. If x represents a number, then write an expression for the sum of a number and 3. My goal is to understand this, so I want to read it multiple times. But now I have something. I've underlined something. I've highlighted important words. So first thing I'm going to do after I read and after I highlight it is do my let statement. So let x equal the number. There's my let statement. So I know they told me if x represents a number, so they made my life easy because I don't need to think of a variable, but I must have that on paper. All right, next thing I'm going to read it again. Write an expression for the sum. When you see that word sum, what does that word mean? Sum means addition. So I'm going to start putting my operation in here. There's my sum. But what things are we adding? It says sum of a number and 3. So what is your number? Your number is x. That's what we said here, that x be the number. So we're adding x and 3. And there's my final answer. Is this what the problem told me to do? I have x representing the number, and I have the sum of a number and 3. Let's try number 2. If x represents a number, then write an expression for the difference of a number and 5. Okay, so we start off the same way, right? I read it once, I read it twice. I'm going to do my let statement. So let x equal the number. That's what they told me, so that's what I have to use. Next thing I need to understand is this word, difference. So when you see that word difference, what operation does that mean? Subtraction. So this is difference. So what two things are we subtracting? It says that we're subtracting the number, and what is your number? Again, x, and 5. So nice and easy, right? Again, these are the simple types of problems. Let's try another one. Here we have, if n represents a number, then write an expression for twice a number increased by 6. Okay, so I color coded this one a little bit more because this one's a little more involved. So I read it again. If n represents a number, then write an expression for twice a number increased by 6. Start with our easy part, our let statement. Let this time n represent the number. So n equals the number. Okay, again, they're telling me what it is. So don't change it to an x. If they say n, if they say b, if they say w, whatever they tell you, that's the number that you must use as your variable. Okay, then write an expression for twice a number. What does twice a number mean? Twice a number means 2 times the number. So 2 times the number, which is n. Then they said increased by. Increased by means addition. What are we increasing by? We're increasing by 6. So we have 2 times a number, or more fancy, twice a number, increased by 6. Last one, n represents a number. Then write an expression for triple a number, decreased by 7. Okay, so I read it once, I'm going to read it again. Let n represent a number, then write an expression for triple a number, decreased by 7. So first thing, our easy part, let n equal the number. Make sure you have that on your paper. You will lose a point if you don't. All right, next thing, we are looking to rewrite. Triple a number this time. So the last one was twice the number. Triple a number means 3 times that number. So in this case, 3 times n. Decreased by means subtraction. And we're decreasing by 7. So here is my math. 3 times a number, or triple a number, decreased by 7, minus 7. All right, so hopefully this first level is getting you into the good habits that you want to take. So let's go on to example number 2. So in this example, what we're doing the same exact thing, only that these are the harder or more challenging, more wordy types of problems. So let's look at number 1. A number more than 20. Such a simple problem, but can be very tricky. All right, so first things first is I'm going to do my let statement. Okay, we have a number more than 20. This time, they didn't tell me what the number was. In the previous ones, we had let X represent the number, let N represent the number. But this time they just said a number. So when they give me that case, I could let my number be any variable whatsoever. To make it consistent, I'm going to just say X. Anytime I think of a number, I usually think of the famous number X. All right, so we have a number more than. Now we know that more than means you're increasing, you're getting bigger. So you're doing some sort of addition here. I'm just annotating it on the top a little bit here. But when that more is followed by than, something weird happens. The order changes, which means that whatever came behind, whatever words came behind have to come in front now. So I'm going to put my addition here. And my instincts are telling me to write just X plus 20. But no, because we have more than, we have to write the 21st followed by the number, which is X. These are the trickier ones because of that more than. So pay attention to more than. So let's try number 2. All right, we have 3 more than. I'm going to highlight that. 3 more than the product of 2 and a number. So just like before, right? We have that word more than. I know that more than means addition. But the tricky thing that happens is that whatever came in front is now going to go in back. Whatever came in back of the more than comes in front. So I just did my little arrow so I remember that. I'm going to start with my let statement. So I'm going to stick with my X. Let X equal the number. Okay, so I know we're dealing with addition. I'm going to put my add in there. Now, whatever came in front, which was in this case 3 more than, that 3 goes in back of the addition sign. So we have 3 more than the product. What does product mean? Product means you're multiplying. So what are we multiplying? Product of 2 and a number. So we're doing 2 and the number, which in this case is X. So we have the product of 2 and a number, we're adding 3. Or, as they gave it us, 3 more than the product of 2 and the number. Let's try number 3. For number 3, we have 2 less than 1/4 a number. Okay, so we have something in front, and we have a new fancy word, less than, and then something in back. So just like the first one, I'm going to just start on the bottom here, giving me some room, and I'm going to say let X equal the number just like before. I'm keeping with the same, but if I wanted to change it up, I can. Now we have the word less than. The word less than, we all know less means we're making something smaller. So we're going to be subtracting. But less followed by than, less than, does the same thing that more than does. It changes the order. Which means that just like before, whatever came in front now goes in the back of the subtraction sign. Whatever came in back goes in front of the subtraction sign. So let's do our subtraction here. There's my minus, there's my less than, and we had 2 less than. So instead of writing 2 in front, I'm writing 2 in back of the minus, and it says 1/4 a number. Okay, 1/4 is 1 divided by 4. That's 1/4. A number. What's our number again? X. So here is 1/4 a number, and we're subtracting 2. So less than and more than. Those are the 2 things that you are going to be looking for to switch the order. Okay, let's keep going. We have number 4. Number 4 says 10 subtracted from triple a number and 2. I'm going to start the same way in the bottom here. Let X equal my number. I love X. Subtracted from. Okay, here comes another tricky one. Subtracted, obviously to subtract, right? Minus, I know that. But subtracted from does the same funky thing as the less than. It does the same thing like the more than. It does a switch, a change order. So we have so far 3 words we are looking for. We're looking for more than, less than, and the fancier one, subtracted from. Okay, so now that I know that, I'm going to put my minus down because I know we're subtracting, but that 10, which was in front, right? It says 10 subtracted from. That 10 is going in back now. So we got 10 subtracted from. Triple a number and 2. Triple a number. We all know what triple a number is. Triple a number. 3 times x. But they made it even more fancy or more complex, this problem, because they said triple a number and 2. Adding 2 to this. And we're subtracting this entire piece by 10. I'm going to star this one because this is one of the trickiest one of all, because we will need extra parentheses because I'm subtracting the entire orange highlighted piece, the triple number and 2. And in this case, this and would mean we're adding those 2 pieces. Okay, so multiple pieces here. Let's take a look at our last 2. So for number 5, the quotient of 5 times a number and 7. Okay, so I'm going to start again with my let statement. Let me try to get at least that point. All right, so we have let x equal our number. The quotient. Whenever you see that word quotient, we are dividing. But I don't want you to do your division with this symbol. I don't want that division. When we are asked to do a quotient in 9th grade at this level, what we're going to do is do a fraction, okay? So here's my division, my quotient, right? So most often you'll see that word quotient. But anytime you see that word, you should be thinking division. And when you think division, you should be thinking some sort of fraction. All right, here comes the easy part because this one's not that bad. We have 5 times the number. What is 5 times the number? 5 times x. And since that was the thing right after the quotient of, that means that piece goes in the numerator, in the top. And then we have and 7. And 7 means that 7 comes in the bottom. So this and is not an addition and. This and is for the division piece. Okay, so that's telling you numerator, denominator, or top and bottom to make it easier. Number 6, the quotient of 4 less than, I'm going to highlight twice the number, and 2. Okay, so we have the quotient. So let me start off the same way, my let statement. Quotient means I'm going to start drawing my fraction, and I'm going to think about what's in the top and what's in the bottom. So it says the quotient of 4 less than twice the number and. This and is part of my division. This is separating the numerator followed by the denominator. So I already know that the 2 goes in the bottom because it's and 2. But the top piece, we have 4 less than twice a number. Don't forget what this less than does. This less than tells me to switch the order. So I know it's subtraction, but where should I put that 4? In the front or in the back? The 4 has to come in back. And then it says twice a number. Twice a number, 2 times our x, comes in front. So here is my final translation. This one might be a little tricky as well, so I'm going to start it. All right, here comes our summary. So when asked to translate a verbal problem into math, you must start by identifying important keywords that will help you translate into math. Always define your variable and slowly break down the words to turn them into math operations, variables, and numbers. Our last step is always to read our math. So keep learning, keep growing, and I will see you in our next video.